So just to give the context, in previous video, we started the partitioning. We tried to understand the entire structure, like database containers, partition key, logical partition on the behalf of, on the basis of partition key. And these logical partition are mapped with the physical machine. One logical partition cannot have multiple machines, but multiple logical partition can connect to the single virtual machine. And that's how this is what the partitioning is, on the basis of what the logical partition is defined, that is partitioning, and on the basis is the partition key. So this is the entire summary of the previous video, and we have to start to understand how to select the right partition key for our workloads, for our application, because partition key is the key to utilize the Cosmos DB to make your application perform better. So there are a couple of factors before you come to the conclusion, this is my partition key. So what are those factors? Let me give you the name first. It is like, not before I, okay, let me do this. Let me give you the factors. Like there is this concept of hot partitioning that we need to understand. There is this concept of single partition query, cross partition query, and composite key. They are these concepts that we need to understand so that we can come to the conclusion XYZ is our partition key as per the need of our application. So we need to understand these concepts. It is just like the concept that I talked about in the Kubernetes storage. So need to understand the concept first, and only then we can get to the correct decision. So let's start with the concept of hot partitioning. What is hot partitioning? Well, as the name says, it seems like something is getting hot. And if you're thinking the way I'm thinking, then you are not wrong, you're correct. Now, what is getting hot? So the logical partition is getting hot here. So it is more like you have decided the partition key. Let's suppose XYZ, and they are like, because of XYZ, they're like 10 logical partition happens. Okay. Now, what is happening? Only out of 10, one is the partition where you are getting a lot of data, right? For example, you chose a particular city, and most of the users that use your application belong to that city. So what does that mean? The logical, you may have 10 cities where your application is working, so you would have 10 logical partition, but all the users belong to the, like most of the users belong to that particular city. Then one of the logical partition is full, it's getting hot, and other logical partition is like cold, if I could say that. This is what the hot partitioning is. So you need to be very cautious, very intelligent when you decide your partition key. It should not be like this, that one of the logical partition is getting all the data and other of the logical partitions are sitting cold, right? So why it will create the issue? We need to understand that concept as well. So now, it could be understood with the concept of request units. Throughput unit here is RUs, because we define RU on the database level or on the container level, and logical partition happening inside the container. So let's suppose you opted for 1,000 RUs for your container, and you would have 10, or let's say 4 logical partition. So this amount that you have done is going to be distributed to logical partitions evenly. That's the keyword, evenly. Let's suppose we started with the 10 logical partition. There is 10 logical partition and you have 1,000 RUs. So it would be evenly distributed on the 10. Okay. Now, one of the logical partitions getting hot. So it will consume all the RUs and afterwards it cannot borrow from the other logical partition. The request is getting failed now. And you do have the RUs in your Cosmos, but these logical partitions are not doing anything out of those RUs. It divide evenly. So getting my point. So this is what the hot partitioning means. If you choose a wrong key, you're making one of the logical partition hot and others are getting cold. So you need to be very prudent, very smart while choosing your partition key. Okay, so basically you are supposed to choose the partition key in such a way that data equally divides among all the partitions. But if you do not do that, then one partition is overflowed because all of your users, because you did not analyze your application, you thought your users belong to all those 10 cities and evenly distributed, but the users belong to one particular city and you made it hot. And this is called hot partition. Okay, so what do we want? We want such a key which divides our data more or less equally in their respective logical partition. Okay. Similarly, we also need to keep in mind the throughput. We don't want hot partition as per the throughput, just like we talked about the example. It was hot partition with respect to the storage. Okay. What do I mean by that is when we run query, it should always getting output from same logical partition rather than spreading to the other partitions. You must be wondering where I'm going now. We're going into different the second concept or second or third concept of single partition and cross partition. Okay, so the hot partition is with the perspective of storage. As I said, if all the users are in one particular city, so all the data belong to that particular, those users belong to that particular city, comes to one of the logical partition, it becomes hot. So this is the distribution on the basis of the storage, hot partition. But there is other aspect as well, which cater the other concepts, that is throughput. Okay, and you know it divides equally, the RUs divides equally on those logical partition. So now let's connect the dots. The hot partition have equal RUs as compared to the cold partition, right? Now let's forget the hot here. We understood we should not do the hot, but hot is as per the storage. Now we started talking about queries. You're running some queries and queries will get some output for you. And while it is running, it is consuming the request units. It's consuming the RUs. Now, if query is running in one particular logical partition, it's called single partition query, and it would not need to go through all the logical partition or reference all the logical partition to get the data out. What does that mean? That simply means if the query is going through single partition, it's utilizing less RUs as compared to some complex query for which it has to go through all the logical partition to get the output. Getting my point? So if your query is getting data out from single logical partition, it's called single partition query. If that query has to reference all the logical partition, it's called cross partition query. And cross partition query is expensive. So the partition key that we're going to define, we need to understand the kind of workload we are running, the kind of query we are running, so that we should be aware. Of course, we cannot get rid of 100% for this kind of situation where the query has to reference the other logical partition. But we could be smart. It's not 100, but we can have like 70% of queries would be single partition, right? 75 maybe, if you are like, if you could analyze it so diligently, so in so depth, you could reach up to 80% of your queries running single partition, single logical partition. So it's single partition query and it's cross partition query. So you see, your query should not send the data in a single logical partition and make it hot. Your partition key should not distribute the data that every other query of yours is going through, referencing all the logical partition and burning all the RUs. So we have covered all the three concepts. The one is left, which is composite key. And for that, we need to understand the limitations. So I think we should go in the next video to understand that. And I hope this video could help you understand the concept of hot partitioning, single partition query, or the cross partition query. So let's meet in another video. Until then, take care. Bye-bye.